all types of problems, right?
Yeah, for maybe like the past 5 years or so, just so we can
Oh,
see like what's the pattern in your problems.
yeah, yeah,
Okay. Also, I feel like they don't really tell you what to prepare. They expect you to do your own research.
yeah. Like um, there are like schools that have like tradition in like Polish Olympiad, and they are teaching like strictly for the Olympiad, like the whole 5 years, right?
Yeah, I mean, yeah, you don't have a choice, right? Are you able
Yeah.
to get their syllabus?
What?
Are you able to get their curriculum? Like what they teach?
Mm, I, I I don't think so. Yeah.
It's
Why would
secret.
they like share it to
Damn.
like people from outside, right?
Can you ask around like is there like a Polish Discord server where you can ask like, hey, I'm interested in competitive programming. Does anyone have
Yeah,
the
actually, there are two Polish servers in Polish Olympiad about Polish Olympiad,
Okay.
and yeah, maybe I can ask someone, but
Just like by like fake dumb, just say, oh, I'm getting into programming and I'm
yeah,
new
but
to
there
this.
is
Yeah.
like uh, playlist official playlist on YouTube that is like
Okay.
for preparing to Polish Olympiad. So
All right. So yeah, because it's best if you have like multiple sources. So use the playlist, but also like see if you can ask around, get some
yeah,
information.
of course, yeah,
Yeah. But I feel like the competition should really like have an official list of
yeah,
problems.
yeah. I
Okay.
think I should.
All right. So right. For now, we'll start with graphs.
Okay,
Where were we? Okay. Oh, you made some
I,
examples.
yeah,
Okay. 0 to 1, 1 to none. Okay. You don't have to say 1 to none. You can just say 1 to nothing, but like you can just leave it blank.
okay,
Uh, I would say there are simpler graphs than this. That's just one node.
mhm,
Okay, in theory, you
okay.
can have zero nodes. I think it's also good to have a test case where there's no, no, it's okay. Okay, let's have one node. I think for your case, that won't be an issue. So yeah, I would say one node is the simplest. One node that's connected to nothing.
Okay.
Uh, can you write that down? One node that's connected to nothing.
Like double C or
Double N.
double N. Right,
Yeah,
right.
there we go.
I knew that something was double, but
It was connecting. No, I'm kidding. All right. Oh yeah, one node that's connected to. And can you show me the actual example for one node that's connected to nothing?
oh, like only okay, okay.
Yeah.
So I was like, mm, adjacent means uh, what was that? The sentence was uh, right, uh, and is uh, one node is connected to nothing.
Huh? Very nice. Okay, I'm going to show you something new. So this data definition is pretty good. In fact, I would prefer this. However, notice how whenever you're dealing with graphs in your competitive programming, when you look at online examples, they don't wrap it inside a struct. They just use the array immediately.
Yeah,
Okay, so this is important to talk about. So I'm going to give a different example. I'm going to talk about, remember day two or day one, we did like a temperature is a number. Remember
yeah,
this?
yeah,
So
yeah.
this is literally saying like whenever I see like 15, I write temperature like if I write an example of a temperature, it's a T15, right? I literally write this.
Okay,
Another way of doing this, a temperature is number, right? Like data, temperature, temperature, let's say value, number, right? That's another way of doing this. And so if we wanted to write T15, then we'll write temperature 15. You see that?
Mm, yeah, right.
That's a key difference between the two. The first difference is that the second one has a struct name.
Yeah,
So like in some sense it's safer because like if someone passes in like I don't know like 5,000 Celsius or something, like let's say that's a 5,000 Celsius
yeah,
and you pass that into something that's meant to like let's change temperature to Fahrenheit, like Fahrenheit 15. The code doesn't know the difference between Fahrenheit and Celsius because they're both numbers, right?
yeah.
But I'm
Okay.
going to change my temperature to Celsius actually. Sorry.
Mm,
But if we wrap it inside a struct, there is no ambiguity. You see that?
yeah,
Okay, so that's a benefit of using a struct. You give it a name, so there's no ambiguity between different kinds of numbers. Uh, Another benefit is that this is a thing in software engineering. You don't need it to know for competitive programming, but the idea of encapsulation, where you hide the details. So when you see a function that takes in a Celsius, you don't need to care what's inside a Celsius, whether or not there's a value. You just pass in a Celsius. So the fields, like as someone dealing with a struct, you don't necessarily need to know the fields of the struct, right?
yeah,
This is more important in software engineering where a program is very big, you can't know all the details. So you use language features that gives you the privilege of hiding certain details so that you don't have to think about them. But if you use a temperature as a number, right, this idea that you're not using a struct, you don't have that benefit. The details are exposed. You need to know about the details. You see that?
yeah. Okay. So it's like we need to have like more information, right? And
Yeah, I mean, more
it's
things to
hard.
think about.
Yeah, yeah.
However, okay, the struct thing looks pretty good right now, right? In fact, in software engineering, we prefer this like the struct approach. This idea of having a class or struct dedicated to your information, but there's a cost. You have to type more.
Yeah,
In competitive programming, this kind of things like wrapping things in struct usually isn't worth it because first you have to type more, you have to scroll around a bit more, you have more code, you're working on infrastructure rather than the problem. Does that make sense?
yeah,
Like these are things you think about when you want to write a big program. If you're making a video game, for example, maybe you'll do this, but in competitive programming, you're spending 1 hour on this problem and that you'll never see again. Doesn't have to be fancy, you just need to get the job done.
yeah. It doesn't make sense. Yeah.
So in competitive program, you actually see more of the first kind. A temperature is a number.
Mm,
Okay? This relationship. But right now, this is expressed as a comment. So I can't like write temperature as a type, right? Like I can't say like X temperature. Okay, let's not say temperature. Let's say Celsius is 15. Like I can't do that. Celsius does not exist.
right.
But if you want to make it exist, you can do this. Type Celsius
Type.
equals number.
Okay.
So I typoed. So let me erase all this.
Hmm.
Let me check the documentation. Is it type? Yeah, yeah, it is. Type Celsius equals number. So let me kill all of this, and if we run this, it should run. Yeah, you see that? We can run our program. It doesn't end with just now with this type, we could do what the heck? Okay, we could do anything. For example, we could do like this number. Let's say not Celsius. Let's say like what's a list of numbers that makes sense? Let's say
Mm,
nodes. We have a list of nodes,
okay.
right? Nodes, and then we can say like one, for example, right? I can run it. So we call this type aliasing. We give we are not creating a new data type, but we are giving an existing one a new name to refer to. You see that?
Yeah, makes sense. Makes sense.
So sometimes in competitive programming, you don't even see people do this. You'll see people write a lot, like in C++, you'll see people write this, like vector, int, or like pair int. Like you see people write this whole thing and you see them write it 15 times. C++, you can actually do a type def. I think it's
Yeah.
this. Like, for example, if you want to do like graph, I actually don't remember the C++ type def syntax. It's something like that. So you can do it in C++. In Pirate is type. There is another thing called new type, but let's not worry about that. Anyway, so let me go back to Celsius. So you have an existing reference. The reason why I'm showing you this is because I actually want you to do this. I know I'm like teaching you bad habits right now. I
Okay.
consider this not a good habit, but for competitive programming, I guess it's a good habit. So I would like you to change your adjacent list definition to be a type alias instead, so you can write less things. Right?
Hmm.
Can you do that real quick?
Yeah, I think I can. Mm, type. Mm,
Also, the a dot array, I feel like let me try something. Sorry, finish what you were doing, and then I
yeah.
want to try something where you don't have to write a dot.
Oh, I must change all of
Yeah.
this, right?
So see,
Uh,
there's less characters to write now, right?
yeah,
It's a curse and a blessing.
like this, right? Or
Yeah.
I am like,
The specifying of the type is optional, but you can do that.
okay.
Yeah.
Mm,
But yeah, we don't have to wrap it in the struct creation anymore because there's no struct. Okay,
mm,
so if you run it, I think it's, yeah, perfect. Okay,
okay.
let me remove import arrays as A. Let me see if
Okay.
I can do this. Can I control D? Oh, no, it's not control D. Is it Windows D? Alt B? No, it's not. Damn it. I'm, I'm trying to find a shortcut to select all A dots. Do you know if there's a
Oh,
shortcut?
I don't think so.
Damn.
I don't know.
I sort of find and replace, but I feel like the UI is not intuitive. So I'm just gonna do it by hand. Check. No way. Declaration wish.
Maybe like include this for like other
Oh,
files.
dude, you don't even need to
Oh,
include. It's
oh,
built in already. Okay. So yeah, you don't have to write A down anymore. Because I'm
okay.
trying to simulate like what you would do in C++. Okay. All right. So yeah, sorry. Let's get back to making more examples. So we have one node that's connected to nothing. What's the next? So remember how like when I say come up with examples, you come with the simplest one and then make it complex by one level.
Yeah,
What's the next simplest test case after one node that's connected to nothing?
like two nodes that are connected to nothing.
Sure, but there's actually one simpler than that.
Really?
Yes. So what can that node connect to?
Like it cannot connect to itself, right?
Why not? Why can't a node connect to itself?
Can it?
Okay, so for our purposes, yes, I know there are situations where it doesn't make sense. For example, let's say Twitter following doesn't make sense to follow yourself. But generally speaking, graphs, like the mathematical graph, a node can point to itself. Yeah.
Okay.
So yeah, can we write that as a test case?
Yeah.
Okay. Okay, so normally I'll tell you what's the next simplest test case. There are some test cases I feel like aren't as interesting. For example, two nodes that point to nothing. The reason why I think that's not very interesting is because that's basically the same as one node that's connected to nothing, right?
Yeah, yeah, right.
Uh, but there is one I feel like that's interesting. So we have G symbol. I think that's a good test case. We essentially have a linked list,
Yeah,
but can we have one where there are two nodes connected to each other?
yeah,
So this is the it's the that would be the simplest cyclic graph where a node doesn't point at itself, right? So that's why it's interesting.
yeah.
Okay. Okay, great. I think this is good enough for us. There is a reason why I asked you to come with those test cases. It will help. So for now, we're working with adjacency list representation. We saw three different representations. Depending on the problem, you want to use one over the other. There are benefits and advantages to each. The thing about graphs is that it's a whole subject. I can spend like many months just working with graphs with you. For
Okay,
now, I want to work specifically with adjacency list. It will get us very far. So I'm
okay.
going to do a gentle introduction to graphs. Then we're going to go back to trees, and then we're going to go to algorithms, and then we'll go back to graphs.
Mm, okay.
Uh, because I feel like graphs are very specialized. I want to get you to know dynamic program as soon as possible because that will open up all many problems. When you learn dynamic programming, you'll know many problems.
That's
Okay, so back
great.
to
That's really great.
yeah. So that's going to be our plan for the near future. Let us scroll down past the examples, and I'm going to give you your first problem for graphs.
Of course.
Okay, given a graph and two nodes, find produces the path from the first node to the second if it exists. Okay, so I we mentioned path in the past, but let me formally introduce what a path means. So in mathematics, a path is an ordered sequence of nodes where every node n uh follows node n plus one, where n indexes into the sequence. Does that make sense? I think this is
Mm,
not a very mathematical explanation, it's a bit rough.
yeah, okay. Kinda makes
Yeah.
sense. Okay.
Okay. This is a really rough explanation. In mathematics, there's a more formal way of saying this, but this is the mathematical definition of a node. Okay, given this, can you follow the design recipe and produce this function?
Uh, I think I can. I think I can. They must like mm, make a template.
Sure.
Okay, okay. So function. Graph template. Uh, are we working with numbers only or
Yes.
Okay, okay, so we cannot send.
Since that's the case
Uh,
for your competitive programming here.
okay. Uh, hmm. And this is this. Okay. Mm, okay. Uh, hmm.
So what a graph is an array, right? What can we do with arrays?
What can I do with arrays? Uh,
Okay, so I'll tell you right now, the graph template isn't actually very interesting.
okay.
So firstly, there are a lot of things you can do with arrays. I don't expect you to list them all, but I would say the most important one is indexing into the array.
Oh, okay.
So
Okay.
then
Makes
I mean
sense.
honestly, I don't even know the syntax. I need to pull it up. Let's see, array from arrays. I really don't like the syntax for arrays.
Yeah, me too.
Wait,
I saw
let me
it.
see if there is a way. Is there a way to index via square brackets? Let me see if that's a thing.
Please, like this would be
Oh,
really great.
I can't even run the code. Okay. Sorry. Let me write dot 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 here. Let me experiment with this. So let's say x equals array one. I can't seem to run the code. Could not type by type Celsius. Oh, because the name's taken. Interesting. Oh my gosh. You cannot use square brackets for arrays.
Really?
Oh my Lord. Dude, I feel like going
Uh,
to C++ right now. Okay.
that would be great. Yeah.
I think the time is definitely coming. It's just because
Mm,
I want you to write tests.
yeah,
That's why I'm still,
I know,
still
I
here.
know. Did
Okay,
you know that they have like rewritten the compiler to TypeScript in Pirate?
oh yeah. Yeah, because the idea is they want to target the web browser.
Okay,
Yeah, that's why they
okay.
did that.
Makes sense.
So, so yeah. Like if I were to write a template for this is what I would do.
Uh,
But I don't expect you to actually write this because I just want you to keep in mind whenever you're dealing with graphs, you're going to index into the graph to get a list of neighbors for a specific node,
so we
and you're
need
going to
a
be doing something
start
with the neighbors.
of right.
So you might even go further. I think this is pretty good. You might do like for full at like and from neighbors. Like you might do something like this.
Okay.
But I think that's a bit overkill. I think just writing neighbors is enough. Okay. Let's and we'll see why the template feels very useless in a moment. Let's keep going. Let's try to solve this function.
Wow. It's like uh mm, what can we name it? Like find path, right?
Sure.
Find path of uh Okay, we need a graph, right? Of course. And then from the first node to the second. Okay, so we need starting nodes, right? And target nodes, right?
Okay.
Uh, okay. Uh, oh, is it like the same as trees that we need to
Maybe.
produce like an option?
Oh, that's what you mean. Oh, yeah. Okay, yeah.
Yeah.
That's a good idea, right? Because the path may not exist. That's a good thinking.
Mm.
Cool.
Okay.
What's the next step?
Mm. Writing cases, right? And tests.
Yes.
Okay. Mm. Find path. Find path. We can start off with the easiest case, right? Mm. Like G1 anything and like it doesn't matter, right? We will still
Okay. Okay,
it
you want
will
to be
be
not
known,
sure.
right?
Okay.
Mm. Okay. Uh, what is the second one? This doesn't make sense to test this. I think like G simple. Mm. Mm. And from
Simple.
0 to 1,
Oh,
the list, right? 0, 1.
cool.
Mm. Okay, the syntax, right? It must be like this, I think.
Sure. Okay. Oh, that's a good test case. The arrows
Uh,
matter.
yeah. Mm. What was G2? Oh, okay, so
Oh. Oh, that's a good test case. Bidirectionality.
yeah.
Okay. I think that there are more test cases we can make with just one node.
One node,
Yeah. There is something we can do with just one node.
like, but this one knows, right?
Uh, could be that also. Yeah.
Let's say Miss, yeah, Mr. Winter points. Uh,
Cool.
uh, Can I do like this just to make it simple?
Actually, when you put it as a 10, that's saying something different.
Yeah,
Because
because it doesn't exist, right?
you're right, yeah. So that's why I thought that was an interesting test case.
Okay. Mm, okay, we can do they rated two times, right? Uh, Jimmy though.
That's a big one.
Uh, a big one.
Yeah.
Uh, two, mm, two, zero to two. Okay, yeah, we can like 0 to 2. Uh, hmm. Okay, but don't like 0 to 2 have like two paths
That's a good question.
because it can go like directly or through node one.
Yeah. So
Okay.
that there are two ways to test this. You either test the one which you think is the one your algorithm will do,
Okay.
or I believe there's a way to test such that it's one of many answers, and as long as it's one of the many answers, the test will pass. I'm not gonna lie, I don't know if
I can just make two tests.
and see which one passes. Okay.
Yeah, it's it's like it's better because you like see which one is true, right? Mm,
Hmm. No, this I don't think this language has it.
mm,
Or does it?
that's too bad.
Yeah, no, it doesn't.
Mm, wow, like so much time has passed. I didn't look at the hour.
Oh, we got 1 minute on this session left. I'm gonna close this one and send you a new one.
Of
I'll send you at
course.
the bottom of this file.
Yeah.
All right.
Hello, hello.
There you are. Okay. Oh, complex. What's the complex one? Oh, that's a lot.
Yeah.
Who goes to five? Three. Okay.
3-0 will be uh 5 2.
Cool. Okay, I think that's pretty good. Are you ready?
Yeah.
Good
I
luck. But you
So
will learn
funny, right?
something. You will learn something. I promise you that.
How will I like learn something if I don't know where to start?
So I guess the template does help you here, right? So you got your graph. You can index into the graph. You have a start, you have a target.
Okay. Mm. Oh, okay. You see the WG. I don't see the WG.
Interesting. That's okay.
Yeah. Uh, Mm. So we
Okay,
need
so
to like get neighbors, right?
yes, yes. So let's start with that.
Uh, I mean, like another function, right? To inside of this to get the neighbors, right?
It's just a function call, yeah, as per our template.
Oh, is this like a real function or no? No,
Like get
it's
which
not.
one? Get now?
Yeah.
Yeah, get now. Yeah, that's how you. That's like the square brackets in C++. That's how you index into an array.
Oh, okay. It's crazy.
I know. The reason why that's now is because I believe the array is mutable. Wait a minute. No, is it, I don't even know, man. I'll check it. So
Um,
what are we getting now of?
oh man. Oh man.
Trust the template. Just follow the template.
You're saying like it's really easy.
I'm not saying it's easy. I'm just saying follow the template. Like neighbors equals graph dot get now, and then what
Okay,
goes in the
okay,
parentheses.
okay,
Yeah.
okay,
Start
okay,
small.
okay. Mm. Wow, the syntax is really messed up.
Okay, so what are we getting from the graph? Whose
Like
neighbors?
the first, the start. Okay,
Start, okay.
okay. Uh, and we need to do something with the neighbors, right?
Yep. What are we doing with the neighbors?
Uh, checking if any of them equals targets.
Oh, yeah. Yeah, that's you can do that, yeah.
How to do that? I okay. I forgot the syntax. Uh, what was the syntax? Can you like?
Oh, let me paste sample code here. Maybe.
Yeah, it will be like easier because I don't think that I
Actually,
must remember the syntax of
yeah.
pirate.
Let me is it did I run it in a
It,
queue? Oh yeah, yeah. I wrote it. I
it's
wrote it in
not
almost cpp.arr.
almost EPB.
So I'll write it above the graph template. But yeah, for future reference, you can also find it in almost cpp.arr.
Almost EPB. Right. Okay, thank you.
Yep.
Mm.
So this is fold. I don't know, is there a specific abstraction you want to use?
Uh, maybe for each, right?
You want for each? Okay.
For each. I think that was in almost EPP, right?
Yeah, there's also that. I'll paste it up top also, just so you can
Okay.
reference it.
Thank you. Mm, okay. So mm, for each node from G neighbors, right?
Okay.
Okay, if node uh, Nodes equals target. Mm, hmm. Cannot like what happened? Mm, okay. But we need like a previous, right? Uh, maybe I shouldn't go to the Olympiad.
Okay, no, there's a reason why this is very difficult. It's because there's something about this problem that you don't know about yet.
Okay.
Yeah.
Uh, oh man.
So at times like this, right, it's useful to think from a specific example. Let's say like G1 line 120, G1 south point. Treat this as your specific example that you're thinking through, right?
Okay.
So what should happen here in this specific example? Like walk me through how it should solve itself. Like don't worry about the code. In words, what should happen?
In words,
In words, yeah. Like line 120, what should happen? What should be the algorithm be doing?
it should like return the list of like the target nodes, right? Or
Okay.
like the yeah, the target nodes, right?
Okay, how does it arrive at that?
It's yeah, it checks if like the starting node has the target node in neighbors. Yeah, and
Okay.
okay, and if so, hmm,
If so, what happens?
it like returns a list of
List of what?
both of them, right? But
Okay. Let me ask you something. What happens if we just use I just realized line 117, you wrote G1 and 00 is none.
117,
Yeah.
where is one?
But
Yeah,
if you already if you start where you're supposed to be, you know, you know what I'm saying?
yeah, but
If if
is
you
it
start at the
true?
target,
Is it true that if you start at the target, you don't think, okay, okay. So, but it is not none because we are not moving.
okay, so we need to go get back to the definition of a path. What is a
Okay,
path?
okay. An ordered sequence nodes where every n node follows n plus one n indexes into the sequence.
So if we have a list of one node, list zero, it does it matter that you're not moving?
Hmm. Okay. I like get what you are saying.
Okay, so there are two. Okay, so this comes to design decision. So there are two answers you could have here. And depending on what the answer is, it's going to affect all the answers you're going to have. Either you have an empty list to say that the path means where you're going. So if you have an empty list, it means you're not going anywhere. You're already there.
Hmm.
Another answer you could have is just a list of zero to say you only need to traverse one node, which is where you start.
Okay.
So depending on what your answer is to this, your solution will be different. So let's come with an answer now. What would the answer be?
Maybe empty. It's like
Okay, so you want the list to mean where you're like what's the next node you're gonna step into, right?
yeah.
Okay, sure. But I think this means you gotta change your other tests. For
Yeah.
example, line 120.
Yeah. And that is it. Right?
Okay. How about line 122? So when we start at
So
node
do you mean
zero,
like this?
yeah, because you tell me that path means where you're going to, right? We start at zero, so we're going to one next.
Okay,
Yeah.
okay.
Uh, okay. Usually in competitions, they're more specific. Like this one, I was ambiguous, and so you had to figure it out. But you've come to this decision. Okay, line 125, so zero, one. Okay.
Uh,
One, two. Okay, so you're essentially just removing the first element from the results, right?
yeah.
Okay. All right. Okay, let's go back to our function now and let's think. So the reason why I asked you to come up with test cases from simplest to most complex is because that's the order of what I want you to think in. I want you to think from simple to complex. So let's start with simple. Let's look at lines 117 and lines 122. Sorry, not 122 or 120.
Okay,
Honestly, you can think 117 to 120. These are your simplest test cases, just one node.
okay. Uh,
How do we get those answers? What must you write in a function? So let's look
hmm.
at 117. How do we know that we are already at the answer?
How do we know that we are already at the answer?
Yeah,
Okay,
because
so
yeah.
uh,
You check it at the start. You don't even look at the neighbors yet. You don't care about the neighbors. You just check it
yeah.
immediately.
Also,
Okay,
yeah. Uh, not this. Can do it like this.
okay. Okay, start is target, what happens?
Uh,
Okay. Now what
okay.
happens if start isn't, oh, by the way, you're missing a colon at the end of line 109.
Where?
Maybe I'm seeing things, but at the end of line, oh yeah, yeah, perfect. Okay. Okay, so if the start isn't equal to the target, what happens?
Hmm. So all of this, right?
Okay,
Oh, we need to get neighbors, right?
get neighbors. But be careful, let's look at line 124. What happens if node 10 doesn't exist?
Hmm. Okay. Okay. Uh, that's okay. How to check that?
Okay, so this is also standard C++. You must check the length of the array.
Okay.
In C++, usually in a problem statement, the signature, they'll provide you the array and the length of the array. But in Pirate, you can do array length.
Wait, I just realized that I don't need to like make else for it because we are returning something to it.
Okay. This if is an expression, you do need an else.
Really?
So in this language, if expressions must have answers, so you must have an else. I don't know if there's a way to not do it like that. Let me check. There is a way. I don't encourage it. Yeah, okay, just do the else for now. I'll tell you next time.
Okay.
All right. So are we guaranteed to be able to get a neighbor from the graph?
We are not, but
We can't.
okay, okay.
What must we check first?
If it's like longer than one, right?
Well, not one specifically, but the length of the array, right?
What array?
Remember, graph is an array.
Yeah, right. Yeah, yeah.
We need to check that the node you're on is actually a node in the array, right? How do we check that?
Oh, okay, okay.
Mm-hmm.
Yeah,
Mm-hmm.
I'm so stupid, right? Mm,
All good, all good.
uh, mm, okay. How to check the length of the?
I think it's a array length. Let me check. Wait, you can also check. Do you have the documentation open?
I don't.
Yeah. It's an array hyphen length, and then you pass in the array. Takes in one thing.
Mm.
But you always gotta have the documentation open.
My
All
bad,
good,
master.
all good,
Sorry.
all good, all good. Is it less than
Okay.
equal to? So let's say the array length is one. So there's only node zero. There's only node zero in our array, so its length is one. Does node one exist in this array?
Okay, wait. So, uh, okay. No, it's
Wait, are you checking if start is legal or illegal?
wait. Okay. I will check if start is legal. Okay.
Okay,
So, mm, uh, so start plus one.
okay,
Start plus one must be smaller or
sure.
equal the length
You
of.
can do this, but the more idiomatic way of writing this is remove the plus one and change the less than equal to just less than. You'll see that a lot in C++.
Okay.
Yeah, so just explain what's happening. So array length is um because we start counting from zero, the final index of your array is always going to be one minus the array
One more.
length.
Yeah. Yeah. Right.
Yeah. So yeah, this is why. So if it's legal, then we can do get neighbors, right?
Yeah.
What happens if it's not legal? So can we write the else case first? So let's jump
Uh,
past the block of code here and write the else
wait.
case.
I will copy it because
Okay.
this way
The
it
the
will,
indentation.
yeah,
Okay.
make it more readable,
Sure.
I think. Where does that end? It ends here. Hmm. Legal.
And then you can yeah, you can tab it. Nice. And so if
Hmm.
it's not legal, what happens?
Return no.
Okay. It's impossible to get a path, right? Path just doesn't
Yeah.
exist. The node doesn't exist. Great.
Yeah.
Okay. All right. We are out of time, so we can pick this
Oh,
back up tomorrow.
we are like really out of time.
Yeah.
Sorry.
No, no, all good now, because I also used the restroom just now, so I gave you back more time.
Oh, okay,
Okay,
okay.
I do want to. Okay, so one thing. Okay, I know as you're doing this, right, you're going to face a lot of hardship. You're going to see something, and it's not going to feel possible, and you'll want to give up. A part of you will ask you to give up. So, as your sensei, I must tell you, you must never give up.
Okay.
Okay, in life, sometimes you have to give up. I mean, it depends on the problem, okay? I can't be specific, but for this specific instance, I can tell you right now that you should not give up. Even if it
Mm,
means you will go to a competition and you come back last place, you cannot give up. Because in life, whenever you face hardship and you immediately give up, you're never going to learn anything. You're just going to start something and stop, right? You're not going to get anywhere.
yeah,
Yeah,
of
so
course.
you must never give up. Now, as for this, why does this, like, in the previous problems I gave you, right, it always feels possible, but this one feels like you're drawing straws out of nothing. It feels like,
Yeah.
so there is a reason why it feels this way. I can tell you right now, but it will spoil to you why it feels this way. I want you to experience this pain to teach you the importance of systematic thinking and the fundamental property of graph that makes you feel this way. There's something about the property of graph that makes you feel this way. And this property is only exists in this form of data and not in the previous ones you experience.
Okay. I
Okay,
The great thing is that I will like sit in my house like today all day long, so I have loads of time.
okay. You are welcome to tackle this, but my hint to you is think about what this property of graph is that made it so much difficult compared to trees, lists, and whatnot. If you can figure out what the property is, you will know what recipe to use and it will make this problem
Is
easy.
this like that we don't know how many neighbors that we have, or I am just
That's that's part
hallucinating?
of it. That is part
Okay,
of it. But yeah, think about what the property is, and you're welcome to tackle this problem. But
okay,
the problem is important. That property is important. I rather
okay,
instead of instead of finding the path, I want you to find the property.
okay.
Okay. Yeah, okay. All right.
So good night.
All right. Good night, Simon, and good luck. All right. See ya.
Bye. See you tomorrow.
See ya.